Hey, what's up, guys? Welcome to day 3 of Unit 7. And so today we're looking at triangles, all right? And so I'm going to start by asking you a question. How do you determine if a triangle is a wrong triangle? Wrong triangles. Maybe you've never heard of that term. Well, that is actually not really a such thing as wrong triangles, but there is a such thing as right triangles. And when I say right, I'm using a play on words there. What I mean is a right triangle is a triangle that has a right angle, all right? And so right triangles are triangles that include a right angle. Wrong triangles, it's just ones that don't have a right angle, okay? And so today we're going to see the relationship between the sides of a right triangle. So I'm going to introduce some vocabulary that's going to be super important for you to understand. Okay, so the parts of a right triangle. Again, right is a right triangle because it has a right angle in it. And so again, we need to remember, just like when we were dealing with angles, right? Whenever you have this square in the middle, that means it's a right angle, okay? And so we have these three sides, right? We have side A, side B, and side C, okay? So the names for side A and side B, so side A and side B, those are called legs, okay? So those are the legs of your right triangle. And what I want you to see is side A and side B always is what forms the right angle. So side A and side B, okay, those is where the right angle is formed. Okay, so side A and side B are always the ones that form the right angle. Side C, right, is called the hypotenuse. Okay, the hypotenuse. Okay, and what I need you to see, this is super important that you see this, is that the hypotenuse is always the side that is across from the right angle, okay? So those are the parts of a right triangle. Again, you have sides A and B, they form the right angle, and then side C is the hypotenuse that is always across from the right angle, all right? Now, what is the Pythagorean theorem? Okay, it is used to find the missing length of a right triangle. Okay, so Pythagorean theorem is what you use to find one of the missing lengths or the missing sides of a right triangle. And the formula is a squared plus b squared. Again, these two sides, we're going to square them, and then that is going to give us c squared, okay? Now, some of you may be wondering, where did you get that? How did you know you had to square the a's and the b's? And if you are wondering, like, where'd you get that from? I want you to hold that. In the next lesson, I'm actually going to show you why this actually works. And so for the purpose of today, I just need you to know this is the theorem, and I'm going to show you, all right, after I've kind of given you this layout, this framework, I'm going to show you in the next lesson how and why this actually works, okay? But for the purpose of today, we are going to use this formula to find one of the missing sides. So in the first set of questions, we are going to be finding the hypotenuse, all right? So in each of these, we are finding, again, the hypotenuse is always the one that's across from the right angle. That's what we're going to be finding first, all right? And I'm going to give you 4 steps to help you, guide you in these. Step 1 is we're going to start by recalling the formula. So we're going to write the formula down every time, okay? And that's just to help us, remember it. Step 2 is we're going to label, okay? We're going to label each of the parts of our sides to know what is each letter, what's the value for each of those. Step 3 is we are going to plug in And then step 4 is we're going to solve. Okay. And again, we're going to solve for the x. Okay, we're going to solve for the x. All right. So, okay. So let's walk through these steps. All right. So step 1, we're going to recall what the formula is. Again, for a right triangle, it is the Pythagorean theorem is a squared plus b squared equals c squared. Okay, so that's the formula. Step 2 is we're going to label them. All right, so again, I want you to remember we're labeling what is a and what's b. A and b always come together to form the right angle. Okay, and so in this case, a we'll say is 12, b equals 5, and then c is always what is across from the right angle. So that is x. Okay? All right? Now, so I have all of my sides. All right? Now, then I'm going to just plug these. Step 3 is I'm going to plug these into the formula. So I have 12 squared plus 5 squared. Again, I'm just taking these numbers and I'm plugging them in. Equals x squared. Okay, I don't know what x is, but it's x, and I got to square it. All right, so that is me plugging it in. Now I'm going to solve for the x. And when I solve for the x, I'm going to actually square these two numbers. So 12 squared is 144. Again, you can use your calculator if you don't know exactly what that number is squared. We're going to get to a bunch of numbers later on that you probably don't know what the square of that is. So just use your calculator. And then 5 squared, okay, 5 squared means 5 times 5, okay, and that is 25. And then we have x squared, okay? Again, don't know what that is. So in order to solve for x, we got to add these two together. So 144 plus 25, that is going to give us 169, okay, equals x squared. Well, now, how do we solve for x when it is squared? So to undo, right, we do the inverse operation when we're solving for x. The inverse of a square would be the square root, okay? So we gotta square root both sides, and that is gonna give me what the x equals. So we square root that. That is gonna get rid of the square. So we got x equals the square root of 169 is 13. And so that is the length of the hypotenuse, the x. So x equals 13. Let's continue on. Let's do one more example. All right, so we start by recalling what again, this is a right triangle. I have this side, and I'm trying to find this long side that is the hypotenuse. Again, I'm going to start by writing my theorem, my Pythagorean theorem. I'm going to recall what the Pythagorean theorem is. A squared plus b squared equals c squared. And then I'm going to label, okay, for this one, okay. Again, remember the a and the b is where the right angle is formed. So these two are the a and the b. And truthfully, where you put the a and the b, that part doesn't matter. So if you get a different a or a different b, that's not gonna change as long as you have the right two. Okay, the one that you cannot change is the c. All right, so we'll say in this one, we'll say that a is 18. Okay, we'll say the b is 15. Right, again, it is just these two that make my right angle. That's how I know those are a and b. Okay, and then the c is always the side that is across from the right angle. Okay, so the c is x. All right, so we have our have them labeled. Okay, now we're gonna say that we're gonna plug these in. Okay, we're gonna plug these in. So we have 18 squared plus 15 squared equals x. x squared. Okay, so now to solve for the x, I'm going to actually square these. So 18 squared, I don't know what 18 squared is. I'm going to use my calculator and encourage you to do the same. That is 324. Then I'm going to do 15 squared, and that is 225. Okay, so plus that, then I got x squared. Okay, so for this one, now I'm going to do the 324 plus the 225. 324 plus 225. That's going to give me 549 equals x squared. Okay, and so now to get rid of that squared, right, because I'm just trying to get the x, try to figure out what that length is for x, I'm going to do the square root of that. That's going to get rid of the square, and it's just going to leave me with x. And so now I got to do the square root of 549. So do the square root of that, and that is going to give me 23.43. Okay, now, and then it's a bunch of other numbers. This one tells me to round it to the nearest tenth. Okay, so the nearest tenth is always just the first number after the decimal points. Okay, and so this one, there's a 3 behind it. The rule, 5 or more, add 1 more, 4 or less, keep it the same. So the answer would just be 23.4 would be the answer. So 23.4. Okay, I just wanted to show you. And again, a lot of cases, it'll tell you what to round it to. Okay, so just because you end up with a really long decimal, that doesn't mean your answer is wrong. Okay, you will probably get decimals for several of your answers. Okay, so that's it. Okay, so what I have shown you is, again, you gotta write the Pythagorean theorem. We labeled, we plugged our numbers in, and then we solved for the x. Okay, so questions number 3 and number 4 are just like the ones we did. Okay, so what I want you to do is I want you to do right now number 3 and number 4 on your own. Okay, so do 3 and 4. Okay, so on your own right now. I am not going to show the work for these. Okay, so I'm going to give you the answer just to check it. But in order for you to have complete notes, you need to be walking through all of the steps that we just did for questions number 1 and 2, 4, 3, and 4. So now is where you pause it and you do number 3 and number 4 on your own. Okay, do not, wait. I'm not going to do these. And if you're missing the work for these two, then you're going to get points taken off. Again, this is where you have to practice. All right, so go ahead and pause it, do number 3 and number 4. If you have any questions, raise your hand. I'd be happy to answer them, and once you're done, you can check your answers. All right, so those are the answers for questions number 3 and 4. Again, make sure you have the work shown. You should have all of the steps shown and not just an answer. Okay? All right, moving on. We're going to go ahead and continue. Now, in the next section, okay, we have 4 problems that we're going to look at, but this time we're actually finding a leg. So in the last ones, we were finding the hypotenuse, right, the side that is across from the angle, the right angle. This time we're finding one of the legs, okay? And so it is a little different, but almost all of the steps are the same, or they are the same steps. And so again, we're going to recall what the formula is. We are going to label them, okay? Then we are going to plug them in, and then we're going to solve. Okay, so let's look at it. The formula is a squared plus b squared equals c squared. All right, now we're going to label them. A equals x in this case, right? Because again, this side and this side is what makes the right angle. All right, so a is x, b is 8, and then c is the one that is across from the right angle, right? Across from the right angle, that is c, so that is 10. So then I'm just going to plug these in. We got x squared plus b squared plus, I'm sorry, not plus, equals c squared. All right, so we solve for x. We're going to square these. We got x squared plus 8 squared is 64. 10 squared is 100. Okay, now to solve for the x, now I just got to move this 64 over to the other side. And I do that, solve for the x, by doing the inverse operation. So minus 64, minus 64. 64 is cancel, leaving me with x squared equals 100 minus 64 is 36. Okay, now to figure out what the x is, I got to get rid of that square. So I'm going to do the square root. Square root. That's going to get rid of that. So I have x equals the square root of 36 is 6. So that is my answer for my side. Or for my A, rather. My one of my legs. All right. Let's look at number 6. A squared plus b squared equals c squared. All right. So, again, which one you choose as A and B doesn't matter. It just matters that, again, where the right angle is made, that's one of the sides. One of the legs, that's the other leg. So these two are the legs, all right? We're going to say A is X, okay? Matter of fact, let's do it. We'll say A is 23. Again, doesn't matter. You could have said A was X. B is X, okay? And then C is, again, C is always across from the right angle. It is 25. Okay, so now we're going to plug them in. We got 23 squared. 23 squared plus x squared equals 25 squared. Okay, now do the square root of these and we're going to solve for the x. 23 squared is 529 plus x squared, and then 25 squared is 625. Okay, now in order to solve for the x, I got to get rid of this 529. I do that inverse operation. I'm going to subtract 529, subtract 529. That's going to cancel, leaving me with x squared equals 625 minus 529. That gives me 96. Okay. Now to figure out what the x squared is, or to figure out, I got to get rid of the square. So I do the square root. Okay. That is going to give me x equals the square root of 96 is 9.79. Okay. And then there's some other numbers. Again, I'm just going to round to the nearest 10th. So because that's a 9, that's actually going to round that up to 9.8. So it will be, when I round it, it's going to be 9.8 is my answer. Okay? So there you have it. All right? So in question number 7 and number 8, okay, again, you are going to be finding the leg. So you know what I'm about to say. Pause it. Then I want you to do 7 and 8 on your own, okay? And then we're going to wrap up the video with one final section, all right? So I want you to pause it. Go ahead and use 5 and 6 to help you solve 7 and 8. Okay, so 7 and 8 is what you should be doing right now. All right, so go ahead and do that. All right. Hey, so 7 is x equals 8.1. 8 is x equals 5.9. Remember, you need to have all the steps written down for numbers 8 and 9. It's not enough to just have answers there, okay? Now, to end this section, okay, you have now a couple problems where you're going to practice, and we're just going to practice using the Pythagorean theorem from there, okay? So most of you, that is all you're gonna do for today, all right? For this last part, I'm just gonna show you this really quickly. The last few minutes, just to finish up this sheet. Here, all we're doing now is we're testing to see, we have all of the sides, now we just wanna see which of these are right angles, all right, or right triangles. So all I'm gonna do, again, the two smaller ones are always going to be the A and the B. The longer side is always the hypotenuse. So what we're going to do is we're going to do A squared. Again, we'll say this is A, this is B, this is C. So 10 squared plus 15 squared equals 20 squared. Okay. Now, 10 squared plus 15 squared, that gives me 325, okay? But 20 squared is 400, okay? So is 325 equal to 400? Because that is wrong, that means this triangle would not be a right triangle. Okay? So, again, you're just using these sides and figuring out if it's if it passes the Pythagorean theorem test, okay? So this one's A, this one's B, this one's C, all right? Again, you just got to make sure that, actually, no, they're all in order. C is always going to be the last one in these, all right? So A, B, and C. So we got 7 squared plus 24 squared equals 25 squared, okay? So just put them, this is 49 plus 24 squared is 576, and then 25 squared is 625, okay? So then add these up, 49 plus 576, that is 625, that is equal to 625, and so this is a right triangle. Why? Because again, once you do A squared plus B squared, it equals these two, A and B squared, equals the same as C squared. All right. So, hey, that's that. Again, you're just using it to test. Listen, I know that was a lot, all right, but it should be pretty simple, right? The formula for Pythagorean theorem is A squared plus B squared equals C squared, okay? Again, remember, the A and the B always make the right triangle. So this is A, this is B, right? And then the C is always the one that is across from the right angle, all right? So, hey, perfect practice makes perfect. So the only way to get better at this is to continue to do problems. Make sure that you finish the problems for, if you need more than one class period, that's okay, all right? It is a lot of work, but again, the more and more you do it, hopefully you can, it'll help you really have a good basis on how to do this, all right? So thank you for your time. If you made it to the end, you're awesome, and hopefully this has helped you understand the Pythagorean theorem. Peace.